Welcome back to the Explainer, SecOps peers. Look, as security researchers and operations pros, we all know mapping out an enterprise attack surface is a totally massive undertaking. Today, we're going to set the stage for optimizing our continuous monitoring workflows. We are officially moving away from ad hoc scanning and building a robust, fully automated reconnaissance pipeline from the ground up. We'll be using best-in-class tools to find those high-impact targets, so let's get into it. Okay, let's dive right into this. According to a recent Project Discovery blog report, a staggering 66% of security teams are basically drowning in manual work. I mean, that is an incredible amount of wasted engineering hours. In modern enterprise environments, manually clicking through web interfaces or running a bunch of disjointed command line tools just doesn't scale anymore. We really need to leverage automation to do the heavy lifting, because that allows us to focus our actual expertise on validation and exploitation. So, to build this automated pipeline, we need to quickly establish our baseline. Think of our workflow in two buckets, passive and active reconnaissance. Passive recon, that's our stealthy data gathering phase. We're talking third-party datasets, internet archives, certificate logs, gathering maximum intel with minimal, if any, direct interaction with the target. Now, active reconnaissance, on the flip side, involves sending direct probes to the target's infrastructure. Think DNS brute forcing or directory fuzzing. Active is highly effective, for sure, but it is inherently noisy, which is exactly why it comes second in our pipeline. Here is the architectural blueprint for today's explainer. We'll be covering the reconnaissance pipeline, passive discovery at scale, active validation and DNS, fuzzing hidden virtual hosts, and finally, advanced automation and mutators. All right, part one, the reconnaissance pipeline. We really need a structured framework to carve away the noise. Because let's be real, in an enterprise environment, raw data is completely useless if it's buried in noise. We need a systematic progression to carve all that away and output highly actionable validated targets. Step 1 uses Subfinder for massive, passive discovery. Step 2 takes that raw list and performs active DNS validation just to make sure the targets actually exist. Step 3 feeds those validated targets straight into ffuf for virtual host fuzzing, uncovering hidden infrastructure. And finally, Step 4 introduces advanced payload mutation to bypass those tricky edge cases. Integrating these tools creates a seamless, scalable workflow tailored right for production environments. Moving into Part 2, passive discovery at scale. This is all about gathering massive amounts of historical data without tipping our hand to the target. This is where we pull all that data without alerting the target's SOC. By running the Subfinder command with the target domain and appending that -all flag, we are commanding Subfinder to absolutely maximize discovery. This tells the tool, hey, don't just use the default sources. Instead, it queries every single configured API source available to it. We are leaving literally no stone unturned in our initial intelligence gathering. Now, what's really interesting about this is to actually power that -all flag, you've got to populate the providerconfig.yaml file, which usually lives in your home directory under .config/subfinder. By dropping authorized API keys in there, like your Censys application ID and secret, you grant Subfinder authorized passive access to premium datasets. Without doing this, you are missing out on massive amounts of external attack surface data. Of course, when you're querying these APIs at enterprise scale, you're going to hit rate limits fast. But Subfinder has a brilliant mechanism for managing this. In that exact same YAML config file, you can actually pull multiple API keys for sources like Censys or Shodan. You just separate them with a colon, it's that easy. Subfinder will then seamlessly rotate through these keys, bypassing those rate limits and allowing you to continuously pull data from up to 38+ passive sources without a single interruption. All right, part 3, active validation and DNS. Time to shift from stealthy collection to actively interacting with the infrastructure. So we've gathered thousands of potential subdomains passively, right? But a ton of those are just historical artifacts, dead ends. We need to actively validate them. This is where the -w flag becomes absolutely crucial for our production environment. It instructs Subfinder to perform active DNS resolution on every single discovered subdomain. If a subdomain is dead or doesn't respond, boom, Subfinder discards it immediately. This instantly filters the noise, ensuring your continuous monitoring pipeline is only fed live, actionable targets. But active DNS resolution comes with its own headaches, namely slow or completely unresponsive DNS servers. So here's a pro tip for you. Use the -timeout flag, followed by a custom value, like 30 seconds. Setting custom timeouts is a lifesaver for gracefully handling sluggish DNS resolvers. It ensures that one single hanging connection won't stall your entire continuous monitoring pipeline, keeps things fast and efficient. And the reliability of these tools at scale isn't some accident. It's totally driven by the open source community. As the Project Discovery blog points out, their community plays a crucial role by contributing code, providing feedback, and rigorously battle testing the software. This community factor, that's exactly what makes Subfinder such a trusted, battle-tested choice for our enterprise security stacks. Let's move to Part 4, Fuzzing Hidden Virtual Hosts. This is where we actively discover targets not exposed in public DNS. And this brilliantly illustrates exactly what we're talking about. Often, developers configure internal or dev virtual hosts on the same exact server as the public site, but they never expose them in public DNS records. Since passive enumeration won't find those, we have to pivot to active fuzzing. By aggressively fuzzing the host header with a word list using ffuf, the fast web fuzzer, we can uncover overlooked vulnerabilities or hidden services that the server is quietly routing internally.
But look, active fuzzing is incredibly noisy. If a server uses a catch-all setup, it might just return a 200 OK status for absolutely every guess in your word list. That'll just drown you in false positives. An unfiltered FUF scan might spit back thousands of junk results, all sitting uniformly at, say, exactly 1495 bytes. But here's the trick. By actively filtering out any response of that exact size, the noise completely disappears. And boom, it reveals the actual hidden Red Hat subdomain.
Let's break down the exact ffuf command to do this. We feed it our word list using the -way flag. We dynamically inject those words into the host header using -h, followed by host:/fuzz.ffuf.me. But the real magic happens at the very end with -fs1495. That custom result size parameter is the exact mechanism we use to filter out those uniform false positives. It is such a simple, elegant way to maintain high signal fidelity in your scans. Finally, Part 5, Advanced Automation and Mutators. Let's tackle some complex edge cases. Because standard pipelines are great, but enterprise targets are messy and complex. In production, you're going to encounter wildcard DNS, catch-all web apps, or complex APIs that only take JSON data over post requests. Handling these advanced edge cases automatically is absolutely critical for maintaining the accuracy and reliability of your continuous monitoring pipeline. So the crucial point is knowing how to chain your tools together to handle all that complexity. Take a look at this setup. We are seamlessly fuzzing JSON data over a post request using the -x, post, and content type headers. But rather than using a boring static word list, we use the --input command flag to pipe in redomsa, an external mutator. It automatically mutates the payload on the fly. This generates unpredictable test cases to discover deep application logic flaws that a static list would just straight up miss. Wow, we've covered a tremendous amount of ground today, right? We moved from massive, stealthy, passive collection all the way to actively mutating JSON payloads. The tools absolutely exist to strip away the manual repetition and give you high-fidelity visibility into your attack surface. So my final question to you is this. How will you integrate this active-passive pipeline into your team's continuous monitoring workflows tomorrow? Take these concepts, build your pipelines, and go uncover what's hidden out there. Thanks for joining me on this explainer, and I'll see you in the next one.